I am Lorin Ricker. I am your humble guide on this little tour. That comet is the one that they sent that little mission robot to touch down on. I thought that'd make a great backdrop for this for no particular reason. I think there's a hidden gem inside VMS.
Is that the one where it ended up landing in the shadow?
Yeah, it did. It did. It was a partial success because they touched down, but the little critter fell kind of over and they didn't get very many good pictures.
And he couldn't get the sunlight.
Yeah, yep. He died a fairly quick death, but God, NASA can do all kinds of stuff. You know, these folks amaze me. We think we're coding tough stuff, and imagine flying a mission to what is it, a comet that you can't even see, and then landing a critter on it. So good stuff. The stuff of science fiction. Well, our agenda today, not to make too much of a mystery out of it, our agenda is to look at this hidden mystery called logical disks. I think they're pretty neat. They're of limited purpose. I mean, it's not going to be a high performance issue. It's certainly, you know, we just got out of the session with Camille again, talking about hypervisors and virtual devices and all that kind of stuff. This is nothing nearly so sophisticated, but at the same time, it's very useful stuff if you know about it. And I'll suggest a few uses for this stuff, as well as showing you how to light one up, how to create a disk, how to mount it, and how to kind of manage it. There's not much there. This is not going to be rocket science. I'll probably finish up early today, but I've got a few slides to share with you. You know, the analogies I can think of in contemporary science, contemporary art, are things like Docker, snaps. In the Linux environment, they're delivering basically a container full of application, and they're delivering across the net. And basically, you plug it into an infrastructure and then just start using it. Well, that's very much what logical disks can do in a sense, and I'll show you how I've done some of that as well. Logical volumes, rather analogous. I'm not trying to make a big deal out of the analogies here, but there's some similarities in the concept. Now, these logical disks have been around for a long, long time, and I'll show you a little bit of the history as well. Really what it is, first and foremost, conceptually, it's nothing more than a file, but it's a file that's treated in a very special way. You can put this file on a host disk, which itself is either ODS2 or ODS5 structured. But since a logical disk is going to end up having a file system built in it, then that file system can be either ODS5 or ODS2. So you can mix and match on the same physical device. You can have ODS5 structure plus ODS2 structure, vice versa, both the same. I don't care. It's however you want to work with them. I hear every now and then somebody say, well, in my VMS shop, we don't use that ODS5 stuff because it involves lowercase characters and letters that we don't understand and spaces and file names. Sure. Well, hell, create a logical disk and play with it and learn it, because it is a learning process to get to, you know, just as far as what are considered more open and Windows-friendly names, shall we say, Linux-friendly names. Yeah, there's some opportunity there to learn some things. Logical disks, because it's just a file, it can be sized to suit your needs up to the size of the host disk. Of course, you can't get any bigger than the host disk, and you're going to use a lot of free space that maybe needs to be used by other things, other applications. So pick your host disk wisely. If you're in a SAN environment like we are, I can turn to my SAN manager and say, spin me up a new volume that I can mount to VMS and then keep private and play with my toys there. So it's fairly flexible in that kind of a thing. You can create as many logical disks as you want, either for specific purposes or for, again, I'm going to suggest experimenting and play as a very valid use for this stuff.
Is your means to keep it private, who mounts it, or VMS protections?
Yes and yes.
Okay.
Yes and yes. Because it has a file system inside it, you can manage the file system inside it. Because you're mounting it, you can mount it private or shared or system-wide or even cluster-wide. Because it's a file, you can protect the file itself. All of these things will go into counting towards access control. I've not played a lot with combinations of those things. For me, it's sufficient to say I want to create a logical disk. I want to either mount it private or I want to mount it as a public disk. And then inside, I just run it as if it had, application or user specific directories and structures within it. But all of the typical conventional things you would do with a disk apply to an LD disk. What's different? It's not a real disk. It's not really spinning rust or solid state. It's based on a real disk, but it's it's not the real thing. It's a file, but you can mount it as needed. I've mentioned private process or system wide. You can back it up separately, or believe it or not, if you treat it correctly, you can just back it up as part of your bigger disk backup, and it's a done deal.
I never thought of putting no backup on the LD disk format.
You could do that. You could do that and then back it up
Yeah.
if you want its contents separately in a save set. Again, you're simply creating a disk out of nothing. There's not something there, and all of a sudden you're going to create something that looks and feels and acts exactly like a disk, except for the physical structure thereof. Why? Well, because it can be dedicated. You can use it for a special purpose. You can kind of go outside. You can color outside of the bounds of what your business unit or your CIO or your CTO actually dictates is appropriate. And sometimes you get away with things that don't ask for permission, ask for forgiveness later, that kind of thing. You can create a very small one nobody's going to notice. You can create a big one for a production purpose because it fits your architectural needs, your use needs somehow. They're very easy to build and create. You're going to manage it just like a disk. So how can I make that any simpler to a crew of experienced system managers? If you're not, we'll show you how. You mount and dismount it independently of the host drive. The host drive has to be mounted. That goes without saying. But then from the perspective of the logical disk, you're free to come and go as you please. It can be extensible. One of the neat things that the author made available to us is that if you decide that the first one you made is too small, tack on some more blocks. You can extend it. It's just a file at that level, but then once you remount it, it's a bigger disk. It's kind of cool. To a dedicated purpose, one of the things I think I'm proudest of this little notion, and I've done this before, Jeff, before our current employer as well, but I got to playing with this at Parsec, and I discovered, hey, this is a really neat place to stick open source languages. When you get when Brett gifted me several boot camps ago, many years ago, with the first port of Ruby to VMS, I was faced with a problem. I don't want to get this intermingled with VMS. Training purposes, we had different things we wanted to do with, I didn't want to get in trouble, so to speak. So I said, well, wait a minute. Now, this is a good idea. This is a really good application for a virtual disk, for a logical disk. So I created one. And instead of installing the Ruby kit that Brett provided me to the system disk, I installed it inside this disk. Now, there's a component in that kit for a shareable image library and a runtime unit. Those went into the system tree, systaller system, where they're supposed to be in a systaller library, I think. And one of them gets installed as a known image. So I separated those out, but then the rest of the runtime guts of Ruby went into my brand spanking new logical disk. And then I got the thinking, well, here comes Python. This is when we got into other Jeff's product, the RMS API. I said, well, this would be a great job. This would be a great place for Python, because when it's delivered from VSI, it's structured very much like the Ruby kit. So I did the same thing. I created a separate branch of the tree. It's all inside this logical disk. The same was true when I got Lua. I don't use Lua very much, but I admire it. And my the web developers are PHP addicts. Obviously, that's the tradition they come from. Can we use PHP in VMS? Well, yes. So I got it and installed it. Jim?
So are you saying that you do the product install / destinate when it equals the LD device?
Yes.
Oh, wow.
Absolutely. Yes. What does product install know? It's a disk.
Yeah, no.
Yeah, exactly. Okay.
How about when you initialize this? Does that have any effect when?
We'll get to, yeah, it does. We'll get to that. So if you use it as a library disk like I do, and kind of a nice place to put the open source languages, the interpreted languages that are coming to VMS, it gives the open source kids, the Linux kids, the developers, et cetera, it gives them a confined playground to draw things from, to use these tools in, and it doesn't have to so-called contaminate the rest of the system.
I
Not-
was thinking for the right word, and the right
Yeah.
word is contaminated.
Well, it is, but it isn't. You could manage this. You could manage this elsewhere. I'm not suggesting this is the only way to do this, but for me, this just became a natural. When I discovered it, I said, I think I want to do more of this and play with it, and it's worked out very well. Other things you could do, isolate an application or an application environment. You could have a logical disk for development. You could have a logical disk for testing. You can have a logical disk for ultimate production use, and just copy files, release mechanisms through those things. You could do that. I mean, probably in that it's kind of a situation you'd want larger logical disks. You'd possibly separate them on different physical disks. You may do some other things. You may separate them by node or something like that. But at least the discipline is possible. You can set up environments for application development. Another thing that I learned at Parsec, I was actually reading through a system manager's manual, and I suddenly dawned on me what I'd been reading and trying to teach was you can use logical disks for training other system administrators. You can give them a safe space, a playground. This is true for user level training right up to graduate degree level system administration. You can isolate folks and their activities inside a logical disk, and then let them learn at their own rate and without damaging other kinds of things. This is especially important when you're trying to train system administrators and you realize that you need to give them some privileges. I'm a big believer in the principle of least astonishment, first of all, but also the principle of least privilege, which says that if you're going to use elevated privileges, only pick them up for as long as you need them and then put them right back down again. This is good business practice, the best practice. But it's hard for a student to come to grips with that and realize what the privileges are doing and why they need them, for particular activities inside of the VMS context. So what I found is that, training with logical disks makes a lot of sense. The thing that dawned on me one afternoon in Parsec class, I was actually the teacher, and I finally read between the lines, and I realized that what the manual was trying to tell me to do was to mount logical disks as volume shadow members. You can build volume shadow sets out of logical disks. To me, at the time, that was a revelation. I was told, is that what that means? Now I can practice dismounting a single shadow member, maintaining the integrity of the shadow set. I can add more shadow set members to it. The documentation for shadow set management is not ideally clear about all of the things that you can do with volume shadow sets. And I've since taken my own learning a long ways by having that kind of a playground where I wasn't going to screw something up system-wide, but I could play with the mechanisms of bringing members into a shadow set, removing them, thinking about the backup steps that could go on, all of that kind of stuff. It suddenly became very, very clear just how powerful shadow set management can be. Try mounting dismounting a shadow set with a bitmap memory, and then make some changes in the remaining member, and then put the shadow set back on and watch how quickly it comes together again. I have a situation, war story, our SAMs are separated by miles between two colo sites. Unfortunately, it's a slow pipe between them. Things work well in production usages, but occasionally we'll lose contact, whether momentarily or for a fairly long period of time between the two colo sites. What happens in that situation is that half my shadow set members drop off. Now we're talking, gigabytes, petabytes. So when I finally get a chance to put those back online because the connection's been restored, it takes hours, no days, to completely copy merge every second member of every shadow set back together. And I can't afford to do them all at once over the pipeline. It's too narrow. It's too low a bandwidth. So I have to space them out over time. This takes me days to do. But at least now I know that if I'm going to intentionally take a set of the second member shadow sets offline for a maintenance purpose, the right thing to do is to dismount them with a bitmap qualifier on them, which causes VMS to start saving the blocks that it's changing in the primary shadow set members. Marks what's different. So when you remount, all of a sudden it's got a whole lot less work to do. And what was the other day, I was anticipating another week of drudgery getting everything back online with the shadow set memory map mechanism. Everything was back online within an hour. I mean, that was a huge savings to me. But the point is, I learned this stuff by playing with logical disks because they can be shadow set members. I think, the rest of this is pretty self-evident. Once you get the hang of this line of thinking, you can sandbox a bunch of software for test evaluation purposes. And I've already talked about the last bullet there. So you got my attention there. Now, the question some people ask, this has been a mystery, and it's probably been a mystery sitting in plain sight for a lot of folks. But how do you know if you've got LD capability on your system? Well, the best thing to do is to look and to ask. The thing to do is to see whether or not with a show device LD, if a device pops up. In this particular case, it's got an allocation class of 4 in front of it because that's the default allocation for this node called Pluto. But there is an LDA 0. That's the pseudo device. That's the prototype device. That's the driver is present device on top of which you're going to build everything else. So if show device LD says no such device, you don't have it, but you can get it and install it. The fortunate thing is that I think VSI has been releasing the LD driver routinely with recent versions of VMS. So it's very, very likely you've got it. But you again, take the time to say, do I have it? Show device LD.
We depend on it for x86.
x86 isn't.
It has to be.
Okay, that's good to know.
The memory disk itself is
Okay,
device.
well, that makes sense.
And in a lot of cases, you just need to start the LD driver.
Right. There is a startup command procedure for it. It does belong in your system manager startup group, but it just basically loads the driver.
What did you say LDA 0 was?
It's called a pseudo device or a prototype device. And it's always present. You'll see other devices of this category generically. We'll also have an XX something 0.
WA 0.
Yeah, there's one. There's one.
If it's enabled, you'll have at least that.
You'll have at least that. That's right. Now, the second show down there is after I've mounted my handy open source languages disk. I just picked a unit number, 256. By the way, pick any unit numbers you want from 1 up to, I believe it's 9999, 9099 is the limit on that. That's a lot. You won't need them all. But I just picked 256 because it was a power of 2 and I can remember it. You can, play numbers games.
Round number.
Pick your own number.
I'm saying, because this is round number.
It's a round number as far as coders are concerned. Yes.
And if
Exactly.
you don't, LD will pick the next available one for you.
It'll pick the next available one for you. You can even, there's even a mechanism to change controller letters from A to B if you want. Yeah, there's a lot of depth there. How do you figure all this stuff out, Lorin? Well, first of all, know that the command to show the version will give you too much information. LD version is your friend there. This is probably pretty much the version everybody's got, especially if it's come on a recent VMS release, version 9.8 or thereabouts. Anything above 8 or 9 is going to be fine, regardless of where you get it.
I can inject another x86 comment too. We use LDM as the logical device pointer to the memory disk.
Okay,
So if you see LDM1, that's the memory disk. Don't dismount it.
don't dismount it. Don't leave home without it. Exactly. The original author, I'll get to who that guy is in a moment. Is his name up there? Not yet. I think we'll come to that in another slide. He was pretty comprehensive in the help text, but he's unconventional a little bit too. He didn't build a separate help text module and stick it in VMS help. He just built his own here. So the syntax to get to help for LD is LD help. So it's internal to the application, to the loader creator application. A lot of words up front, shows you some basic formats. I did a little bit of ... because the additional information group is pretty long, mostly because it's new features in version 5.0 all the way up to version 9.6. I don't think he bothered with the latest versions because they were just probably mostly bug fixes or minor feature adds. The ones down in capital letters are the guys to the commands to focus on. And we're going to talk about 4 or 5 of them here. Connect, create, actually in the opposite direction, create, connect. We'll talk about mounting and all of that kind of stuff. And then you can dismount and disconnect a drive as well. Some of that stuff down there with the tracing and the no watching is pretty esoteric. I'll get to a pointer on that here in a moment. Here's the author. I don't know if anybody has met Mr. Vanderberg or not, but he's one of these intense coders from Europe who just really contributed something major here. He wrote this back in the 1980s. I think actually a predecessor started the project off from what I remember back in the 1980s, and your Vanderberg picked it up probably in about version 4 or 5 thereabouts and has been moving it along for years ever since. It's still available from his website, Digiatator.Netherlands, NL. And you can certainly visit his website. It still chimes up. I checked it out the other day. Well, there it is right there. Took a screenshot of it to see what was going on. If you follow on the left-hand menu, if you click on LD driver itself, it'll get you to a page that not only will let you download the VMS ready driver for your particular flavor of hardware, but it'll also point you at a digital technical journal article. You remember the digital technical journal, the DTJ? Well, he actually wrote a very, very fine article about the LD driver and published it there many years ago. Fortunately, he's also replicated that very same article in that subpage of that website. So I highly recommend that if you're going to really dig into LD driver, you pursue his article and read it cover to cover, because he'll tell you an awful lot of stuff that I don't have time to cover today, or even haven't bothered to experiment with yet. Yeah, there it is. An excellent article by Mr. Vanderberg. It's called Disk Partitioning on VMS, and there's the pointer to the actual PDF itself. But that was published in June of 2005 in the Tech Journal itself. I still have a complete copy of the technical journals. Kudos and credit to VSI. They've also replicated the whole library on their website. So we have access to the full library of technical journals. They're a godsend. Okay, I think we're pretty much along here. I had questioned whether this was available officially from VSI. I'm pretty sure it is. I'm pretty sure, as I saw a couple of head nods, that it is available in the distro kits for VMS integrity and alpha versions. I don't have any information at all whether it's porting to x86. I hope it is. I don't think it'd be a big stretch to port it.
It's present.
Is it present? Good. Done deal. Okay, how to do it. If I've got you all jazzed up about why you might want to do it and play with this, my font changed there. The basic steps are these. You do an LD create to actually create the file on disk. It's going to give you some options to specify the size, and really very little more. And you'll be naming it. You'll be essentially designating how it's connected to the LD driver with the LD connect statement. That's where you say this file now goes with LDA 777. Then all of a sudden, LDA 777 is going to show up in your show device LD display because you've connected the physical file that you created to the physical device which you're now connecting to. Does that make sense enough? At that point,
You just enter these commands like LD create, and I'm not specifying the device or the location or file or anything like that. Is it going to prompt me for?
No.
It's not.
No, it's not. You're going to need to learn the whole command, which we're going to show some examples of. So it's all specified on the command line. This is true command line system manager stuff.
Okay.
So it's not, there's not very much that's, you know, intended to be user-friendly here, but this is stuff you're only going to do rarely, or you're going to embed it in command files. So you'll get the hang of this real quickly. The same is true for the connect. There's a few options, qualifiers on the command line that you'll use. Excuse me, I just caught the bug in my throat. You get old and your voice goes away real quick. Once you've got the device connected, then what you're going to do is actually initialize your disk. It's a logical disk. When it's connected, it's just raw. There's just junk in there. There's nothing in there. You do an initialization of it, a standard initialization command, and all of a sudden it comes to life with a file system in it. You get to choose structure 5, structure 2, ODS 2, ODS 5. You get to specify a few more things. You'll certainly be putting a device label on it, a volume label, just as you would do with any other physical disk, because then you're going to turn around and mount it, just like a disk. At that point, it is a disk for all intents and purposes. So, like I say, manage like any other disk, mount when needed, or you could mount it permanently, dismount when desired, back up prudently as needed. What I mean by some LDs are disposable, I don't quite know, but it must be intelligent.
I think if you have to use a qualifier to make it survive a reboot.
No, there's
Okay.
it'll survive a reboot if you don't tear it down.
Okay. Then I'm done with that.
I don't remember what I had in mind there either. Sometimes I write to that.
Yes, you do have to mount it again.
Oh, yeah, you'll have, after a reboot?
Yeah.
Yeah, you'd have to, yeah, if that was your comment.
They don't. Rebooting and it's still there.
It's gotta be mounted, no, it's gotta be connected and mounted somewhere.
Yeah, it is connected and,
Maybe
yeah. Look, these are the things you get to experiment with. That's why I encourage play in this environment. It's very free to, very easy to learn stuff. Again, the basics in order. LD create, basic parameter is going to be the name of the file itself, and you get to be as creative or as boring as you want to be with naming that file. A lot of people will, what's the convention? I think the author has been using .dsk as kind of a conventional file extension, but you don't have to do that. You could call it .sam or .lorin or whatever you want to call it. Then the LD connect, and that's the place where the file is connected to the actual device driver through that artifice of a virtual device. Then you initialize the device with a volume label, then you mount the device however you want, and you're off to the races. Then it's just a disk. It's going to behave that way. You can do show device LD on it, /full on it, and mount it as I say, even /system. Excuse me. There's even a /cluster qualifier. There's a bit of several paragraphs in the author's technical article about mounting, fully shared across the cluster. There are a couple of tricks there. I didn't replicate those here, but they're not hard. It works even across a cluster. Oh, excuse me.
Lauren, before I asked about the effect of initializing a logical disk and having the effect on the parent, and you said you get to that, does it?
Does it have any effect on the parent disk? Other than the space it's using, no. Well, and it's going to impose an IO load if you've got, extra folks really going at the logical disk. But no, it's just going to be a file on the disk. As far as
how to expand it.
I don't have that slide prepared, but most of these things are really well covered in the online help. So just look for /extend on the create, I think is where it is. So you could just go back over an existing drive and actually extend it however many more blocks you need.
There's create/size.
There is a create/size. That one is for the initial size, Jeff.
So if you did it again, would it enlarge it? Let's say.
I don't know if that would work that way or not. I do know there's an extend qualifier. So that's, I tried to include at least a little bit of code here. There is a real create statement, as Jeff was just saying. /size, there's a small one, 1,000 blocks is just a toy. My OS languages disk is 1,000,000 blocks big because I had the space. And so you can certainly work up to that size and beyond. I just suggested bootcamp _demo.dsk as the disk name. The /log just produces the information message below. And /contiguous, think about that one. If you're on spinning Rust disks, it's still okay to use that, but /contiguous doesn't mean anything anymore if you're solid state. So don't even bother to worry about that.
If you specify the name without path.
No, it's going to be here
It is needed on your current disk.
on your current working directory. Yeah, I didn't show you the steps of putting, directories and subdirectories around this, but it does suggest, you see there in the information message, DSA 404 programmers.ricker.tools.ldtest.demo. That's where I'm at. So, you can segregate these things into subdirectory structures and hide them or make them public. You choose how you do it. It's just a file at this point. Now, down at the bottom, LD connect bootcamp _demo disk, the one right here that I just created, to LDA 777. And I did give it a, no, that's the place where I actually start up with the proper labeling for this thing.
So 256 already existed. Now you're creating one.
One more.
Okay,
If
and
we
that's
did
where
this,
you're naming it.
right, and I think if I'm not mistaken, the next slide
Yeah.
shows it
Okay.
down there. Shows that it's there. But notice it's online, but it's not usable yet. So
I would name it, instead of bootcamp, I would name it LTA777.tsk.
I actually, Jeff, I wouldn't do that because you may find it prudent downstream to rename, to reconnect it to a different device, not LDA 777. Come up with descriptive names for stuff. Don't just name stuff the same.
Yeah, I thought that you would want to, okay, I see where you're going.
Yeah, your command files can remember that. Your mind can remember that, but you start getting into problems if you do that kind of stuff.
I use the /contiguous. Will you keep looking on the current default until it finds a chunk big enough to actually create contiguous, or how does it work with contiguous?
Without contiguous, yeah, it's just going to piece it together in file extensions.
Yeah, but you keep looking. So for instance, we'll not just take the first block available on the current default. We'll keep looking until it finds a long enough block.
Oh yes, with contiguous, it works like contiguous does in other commands. Yeah, if you demand /contiguous, although that doesn't mean anything anymore on solid state, but on spinning Rust, it's going to say, okay, I've got to have this much contiguous blocks in order to allocate this file at all.
If there is no contiguous block big enough, then it just fails.
Yeah, it'll just tell you I can't do this one. So you either defrag your disk or something.
Or your connect command there, you put a volume label, when it shows the initial syntax, you connect it and have a volume label.
That's not a volume label at the end. Actually, what that is, it becomes a logical name which points to LDA 777.
Oh.
Thank you, Jim. That's right. I
So-
misspoke.
Like, you can leave the LDA number out if you don't care what it is. Your LD connect disk, and I'm not sure if you put an extra space in there or not. You do something to separate that, and then you put the last number and the last qualifier in there. And what happens is that becomes a logical name that points to the LD number it gave you. So if you just don't care what it is, if you need to make an LD disk for something that's temporary, like you want to, just stash some files, and you don't care which one it is.
Yep.
You can go create, don't give it the number, it'll give it the next one available, and it'll stick the device name into the logical name at the end. So then in your next command line, you can go mount Boca demo,
Yes.
and it will go, in this case, LDA 777.
Yes, another good points. Thank you for that. And another good point to know about Connect is that it includes a / I think it's called /symbol qualifier. And if you impose that, it'll actually build a
Yeah.
DCL symbol for you with that same information in it. That makes it useful for on the fly in command files. Exactly what you're saying, Jim. So show device LD. Now we've got LDA 777. I want you to note that it's online. It's not mounted. It's not even initialized. Here's how we do that. Just like normal stuff. Initialize, in my case, I picked ODS 5 as the structure, LDA 777. You see me keep using the colon after that. Memory serves me, the Syntax is a little bit picky about not having colon on certain of the LD
It prevents
commands.
it prevents it from being accidentally interpreted as a logical name.
Probably so.
You don't know if it's the
Yeah,
device.
if somebody has a
Well-
logical name out there called LDA 777, it's going to try to do logical name.
It could,
translation.
it could do that. In any event, you'll get some warning bogus if you not using the colon at the right spot. So I just tried to show you use
It's not a
colon every.
device name without a colon.
It feels right, doesn't it? It's like hot dogs without mustard or whatever.
But does every file have to have
Yeah.
an extension?
Well, yeah, that too. But anyway, there we actually initialize it, and the init step can be silent.
Oh, I like the file.txt if you want to hide something.
Yeah, yeah, exactly. And then you turn around and mount it with a label. In this case, I'm doing a process private mount. But I could include /system, read the release note, or read the technical journal article if you want to venture into mounting it /cluster, because it's possible. I think what he's saying there is just be real sure about your allocation class numbers.
And making sure it's in the same spot and seeing exactly the same LBN location, all the members in the cluster.
Yeah, exactly.
And there's a funny /lock switch that you had to put in there that I don't think you need it anymore, but I always put it there because somebody told me to in the past.
That could be. Well, read the text. I don't think it's particularly tricky by any means. But at that point, once you've got it mounted, it's a disk. You play with it. You use it. You put it into production if you need to.
Right.
You will need to create directory structures inside that disk. I mean, the init command, of course, creates the master file directory, the top level 0000000 directory with all of the standard stuff in it, the index file, the self pointer to the directory, all of the other .sys files. They're all there. It's a real disk.
It's exactly like doing a fiber channel present of a new line.
It feels a lot like it, doesn't
It's
it?
exactly
Yep.
like.
Yep. So once you've created some internal directory structure, you can then start using it, create a file, edit a file, compile a file,
In fact,
execute a file, whatever you want to
in
do.
fact,
Set
this
the
is a
phone
very
to
good
directory.
way, at least I am using for updating, reinstalling VMS layered products.
Yeah,
Because when I had to remove DECnet Plus and install DECnet 4, I copied the VMS ISO
uh-huh,
to one of my virtual disks.
yep,
Created a logical disk
yes,
with LD. And that's it.
perfect use case, absolutely.
The correct statement, I think, is you can do everything with this except blueprints.
Yes, I think that would be the one caveat
With one exception.
yeah.
And talk to me at the train table tonight. I'll tell you what it is.
Tony,
What is the effect if you dismount it? You have Lorin.tsk is your file
Okay.
for it. Okay, you dismount it, and then I want to copy it to another physical location on another disk.
Yeah.
Is it still usable?
yes,
Absolutely.
it's just a file at that point. Your copy command sees a file full of arbitrary stuff. Copy can copy anything.
So
You
I
can
have
back
to
it up
do
to another
connect.
location. Yes, you can.
And then you connect it with the new location.
Yes,
A matter of fact, we're actually using this to do guest, host, guest,
perfect.
one day KVM.
See, my talk is done. You guys are already doing a lot of good stuff. Those are great use cases.
What if you tried to bring it up in both destinations?
Well, you'd bring it up on
Copy
bring it up on different unit numbers.
Okay.
You couldn't use the same unit number. They're now different files.
And when is the file ever locked? When
It's
you mount
locked.
it, is it locked?
It's locked when you do the LD create command. If you look at the parent drive, you'll see the reference count gets bumped by 1.
You can't delete it.
No, that doesn't mean, that's not what lock does.
Oh,
It's perfect. If you can, once you get it dismounted and disconnected, then it's just a plain ordinary file and you can
right, but
delete it.
but while it's mounted, you can't delete it.
No, you can't mount it. It's a disk.
While it's mounted, you also cannot dismount the parent disk.
Yeah, it's an open file. It counts as an open
Yeah,
file.
that's what I meant
But-
when I said lock. I mean, open, yeah.
The reference count gets bumped when you do the LD connect. you don't even have to have it mounted and that number will go from.
I think you're right. I think
And
you're
as
right.
long as that number is more than one, the parent disk cannot be dismounted.
Right.
It doesn't matter where you put the DSK, really.
No, that's, I really like this idea of using a text file. I love it.
A text file as an LD,
Yeah.
I really obfuscate the
I love it.
purpose. Yeah, why not?
And then
I don't-
then I just mark it no backup and it's mine.
Yeah, it's yours forevermore. Exactly.
We're even starting the DSK on the host. So it's not even on VMS. And then we translate it as a virtual CD-ROM.
Yeah.
So basically start on the host and then the VMS is there.
There you go. There you go. Very, very flexible stuff. I'm, with this kind of discussion, I don't want to belabor any points. You can see here, I'm dismounting LDA 777. It's back to the state of being a dismounted, but still a disk as far as we are concerned. You'd have to try to mount it again to be sure. Obviously, if you're reusing a previously created LDA, I say this just because to be explicit, don't reinitialize it because it's already got some good stuff in it. So, at that point, you're just going to mount it. If you put it in a startup command group like I do with my OS languages, I've just got a section to mount that disk. I don't even consider it a file anymore. And that's where I remember what logical unit I've given it is right there in that context. And so everything comes out just hunky dory.
I can add just a couple more x86s.
Sure.
Because our memory disk is a .dsk file, sys.dsk. It is an LD device and it is bootable. We have a procedure, MD write boot, that creates a boot block.
There you go.
on
That's
that
right.
logical
That's right.
disk. That logical disk is within your main system disk.
Right.
So the main system disk boot blocks point to the logical disk and use its boot blocks to boot.
Yeah,
Okay.
you're so about that.
So
So they're okay.
it
There's
is a
1.5
disk like any disk. You
There's
can-
1.5 cases where you can
Yeah.
do from it. Now, think what the other half is
Mm-hmm.
tonight.
The other thing, the / contiguous qualifier. There's also a / best try.
Oh, yeah. Yeah, that's true. That's true. And
What we found early on, in engineering, we're recreating memory disks all the time.
Sure.
As we're developing, and eventually we're running out of contiguous room.
Yeah,
in the disk. So we actually had to modify both the boot manager and these utilities
perfect.
to allow us to specify a number of extent records
Yes.
that were acceptable.
Yeah.
Yes.
And I believe that was 3 initially, and we may have bumped it up to, I believe, 20.
Okay. Well, from that command perspective, I just want to say from that command perspective, things have been very thoroughly developed along the lines suggested by other VMS utilities like, copy has a contiguous / best try, et cetera.
Yeah.
So, a lot of the right stuff has been mimicked into this driver and the set of command command capabilities. So
Assuming that you
go
draw a
ahead.
line in a multi-header file.
Yes.
Carrie, go ahead.
So just playing around with this virtualization all over the place type stuff.
Yeah.
How different is booting from an LD disk than booting off a VMDK file on VMware? So in other words, the VMS actually be the host moving a whole bunch of LDs if you had a multi-VMS development environment. It sounds a lot like what you're doing.
I think MDK might be a different format, right?
Yeah.
This is seen as a OBS or whatever you initialize it.
Right.
So
Yeah,
that's a very good example is when we were playing with this, one of our senior engineers was like, oh, take this and was not ISO. I was like, okay, simple, right? So we go KVM, we put the path to this .iso, VMS side, everyone is happy, right? And I was like, oh, great, okay, I'm gonna take and add one extra file here from Linux, it's an ISO. And I was like, system cannot not, system cannot not. And then I went to the head and was like, this is not an ISO.
Yeah.
So they just renamed ISO so that KVM would just go ISO, go. And KVM doesn't care if it is really an ISO.
People,
So it is
I-
an OBS system.
yeah, I,
Point, if you think about it, like, VMware is just an OS, a low level OS,
Yeah.
but hosting LDs.
Yeah.
Yeah.
there are all kinds of possibilities for extending this kind of concept. The point you're making about just renaming a file to b.iso, file extensions don't really matter. They're conventional.
Exactly.
It may be that the Pascal compiler understands that it should compile a .pas file if you don't say so, but it'll compile a .lorin file just as happily if you specify
Yeah.
the qualifier. So, you know, the Linux Unix community has always had this a little bit more right because they've always had a capability of peeking into the file and seeing what it really is, as opposed, we're done. Seeing what it really is, as opposed to believing the naming convention, whatever that might be. Jeff, go ahead.
Two questions, shadowing, so shadow set breaks, comes back, you know, a couple hours later, so the main disk, I mean, all the, you know, the shadow sets are gonna synchronize at the same time. So is this gonna be replicated? Is this?
This won't be auto-replicated, probably.
So you get the shadowing, the synchronizing will be redundant, done twice.
You'll,
Think of it as two physical spindles where one of them falls out and you have to bring it back.
Yeah.
The other one back into a shadow set.
Yeah, you'll have
Curious, yeah, just curious,
Exactly.
yeah.
well, and you can practice this at home.
Yeah. Second question though, privileges. So you said this is used to train system managers. So, you know, if you have operative or whatever you need to do the init and the mount, the same applies to a logical disk. You need the same privileges.
Well, yeah, but consider the fact that if you own it, you don't need privileges. And in this case, if you're working in your own playground in a subdirectory of your own, tagged with your UIC, you can create any file you want in there.
Sure, just like you can create
When you
block file, sure.
When you create an LD file, it's going to be tagged with your UIC.
So you don't need
You own it.
And you
When you
have-
initialize it, you're still going to own it. When you mount it, you're still going to own it. You're the system manager of that disk.
Good, okay.
Now, you can start playing games. You can start setting up structures internally that allow other people to use it or disallow other user classes from using it. So that's where, I mean, it's a great playground for training a system manager so that they can experiment with things rather than just asking questions and getting a hypothetical answer back.
So you can own an LD file, and when you connect it and you mount it, you can actually set it up so you yourself can't do anything with it. Don't give yourself a directory on that disk that you can write to, and you won't be able to use your own file.
The caveat there is the catch-all phrase in VMS privilege and file access management is that you can't relinquish control of devices or entities that you own. You cannot relinquish control. Remember, there's no control bit in the privilege mask. It's always implicit. And it took me a long time of struggling with that.
Oh, yeah, you're right.
You can't give away access to your own thing unless you have privilege, which means you still have access to it. But if you give it away to somebody else, that is to say, tag that file
You're
with a
right.
different UIC.
The OW field matches by UIC, you're right.
Yeah, everything is done by UIC unless you go to access control lists. And even there, the same kinds of rules apply. But again, it's a great playground for bringing up, young system managers. This slide, I've said everything already, so I'm, in the interest of time, let me just flip through a couple of things. Yes, you can dismount. We've talked about all this.
Yeah.
We've talked about all of this, and I did provide you in this particular session with a couple of command file scripts in the repository I'm going to get to in a moment. To be perfectly honest, after I wrote these scripts, they're pretty finicky and particular about asking questions about everything that you need along the way to build a brand new LD disk. And I think it's more finicky than it needs to be. Current practice, I just build it on the fly. I just type the commands out on the fly. But it's all there just so you have some documentation about how I've been doing things. We're done summarizing. We're done wrapping up. Question I asked the other group that I gave, how many of you would actually be interested in a lengthy DCL type class where we get into the kinds of things we did yesterday? How about a TPU class?
How about an LD class?
How about an LD class? We could.
Class on LD.
You might have to teach it, or we'll have to collaborate. There's a lot of experience in these groups. No one of us knows everything, and that's the good thing. We're all here to help.
You didn't cover it, but a fast snippet, and this will become easy for people that know fiber channel. On a fiber channel disk, you can go to the array, you can tell the array, add 20 gigabytes, and it'll grow your container file. When you go back to VMS, VMS knows that this got bigger, but its size hadn't gotten any bigger. You do set volume / size, and it will grow. In order to do that, you have to initialize it / limit.
Yes.
Once you do that, it gets a little message. I'm using 16 block granularity. And then you would be able to extend that LD dynamically without being able to mount it. Let's stay online forever.
Let me help you a little bit with terminology. You say granularity, make sure people understand what you mean is cluster size.
Cluster size, you're right.
You're-
And that's actually what the message says.
Yeah,
It says
yeah,
using the full cluster size 16
This
blocks.
is another great use for this as a playground tool. Because the disk extending can be tricky. It also depends on the amount of bitmap space that's
Oh, yeah.
that's built into your init command. There are qualifiers on a
Yeah,
init to
you
control
can
all of
create
that,
it-
but there's a lot of stuff.
You can create a disk too small that it can't create the bitmap. And that
Yeah,
will
that's
fail.
right. That's right.
Yeah, I have one interesting gotcha using the LD devices. I was using, like your example said, I was teaching a VMS class
Sure.
and wanted to demonstrate volume shadowing and mini merges and all this kind of good stuff. So I created the individual LD files, put them into a shadow set, and the shadow server went berserk
Really,
because I created the DSK files on shadow disks.
really.
And then when I started to do shadowing of the LD drivers, the LD devices, it just came up with loads and loads of Opcom messages.
I didn't have
and
that problem.
verifications. I know it happened to me on more than one occasion on my own system at home, which is in 8.4 alpha.
Yeah.
And on the BSI test systems, which were
There's-
I haven't run it. That scared me to death.
It has to be
I
multiple.
remember, you know what, that might be in the section in the help file where it talks about how to do cluster wide LD.
Maybe.
Thing in there says there are a couple of different rules you have to follow, and if you do that, it'll work. That same section might also say something about shadowing. It's been a long time since
Yeah,
I've been in
yeah,
that part of the help file.
We would all be well served since there's such a wealth of knowledge here. I thought I was going to teach a bunch of newbies, but you all helped this talk very much. We should get together and figure that one out. I'd like to know about that pathological case.
In all reality, I thought you were gonna talk about the other things like watch and all that fun
Oh,
stuff.
I wish I had time to really delve into that. I haven't been there very deeply yet.
LD has another command that says /watch. And basically, the LD driver will intercept all QIOs that go to that device and tell you what they are.
Yeah,
So.
which is interesting for the first 10 and then boring from that point on, but
Well,
but it depends on what you're
looking
trying to track down. Yeah, there are some deep capabilities in there. Again, the technical journal article, he does cover those things, at least enough to get you started. Explore and, knock yourself out on that kind of stuff. I want to close by saying, I try to be as generous as I can. This is a repository I set up explicitly for this boot camp. It contains both of my sessions. It's for those of you who can't quite see everything, it's at GitLab, not GitHub.com, my name, Lorin Ricker, /bootcamp, VMS Bootcamp 24.get. If you want to go at this with a browser, just replace the get @ sign with HTTPS// and you're on your way. For those of you who don't know that trick, another gentleman was trying to make get @ work in his browser. So there you go. Thank you very much. I appreciate your kind attention and participation.